So as people are finishing up in class, I went through this whole spiel about the rearrangement of letters. We're talking about permutations here and doing these notes. We did license plates right there. License plates yesterday, so we should be okay with this example and the notes that I have here. Press pause on the video, look at that, and then move on. But really made a big deal about permutations where order matters, and we're going to have a permutation formula coming up here. But the first example was how many different ways can I rearrange the letters dragonfly? They don't have to be words per se, but different arrangements of the letters. So all 9 letters rearranged, it's 9 factorial. 9 letters in the first position, I choose one. Then I have 8 I can put in the second position. Blah, 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 blah. Don't look at that Mississippi. That's a different example. That made a big idea about how is butterfly different, and how they're different is when I switch these two T's, I still have butterfly. So that's a repeated, non-different arrangement of letters. It's the same word. So that has to do with combinations, by the way, when we get to that part. And I'll move my face here. So I'm up here, just so you know, I'm in class with my mask on. So what ends up happening with this is you have to account for those repeated scenarios and divide, because every word that I write, I switch the T's, and that's a repeated of the same word. So I have to divide those repeats out because that doesn't count as a different set of a different arrangement of letters. You wouldn't recognize it. Then Bumblebee gets nuts. There is actually 6 different ways I could rearrange those B's and I would still have the word bumblebee. So 3 repeated letters, 3 factorial non-unique ways I could write that one word. But then unfortunately, I also have repeated E's. So I got to divide by that as well. There's 3 factorial different ways I could rearrange these and still have the word bumblebee. By the way, 3 factorial 6. 6 times 6 is 36. There are 36 different ways I can write just that one word, bumblebee, by the way that these letters can be rearranged. So that's why every word, there's 36 different ways that they could be written and still be the same word. So that's why you have to divide by that, because it's not unique. All right, that has to do with combinations. All right, here we go. So now I'm in. Hopefully, you all turned in your sheet there. And then look at this. I know you have this in front of you, but it's for speed. Maybe get a highlighter and really highlight that formula, because you're going to have that memorized. All right. So, what's a permutation? The biggest thing you need to highlight as well is this is when order is important. This is when order matters in a question. All right. And it did matter in Dragonfly. And it also mattered in Bumblebee. But Bumblebee, actually, I can equate it more to a combination when I go to that formula, and I will, but I'll hold that. So permutation means order matters. When you change the order, you have a different scenario. I guess I'll turn this as a way of, we can see the screen and also see it on here. Double look here. So actually, taking 9 letters of Dragonfly and seeing how I can arrange all 9 letters differently, that is actually a 9P9. And I don't know why I was hiding that. You see that. Go to your calculator right now. Hopefully, I have it open. I do. And I went ahead and calculated that, and you got the same answer as what we got up in the notes. But you need to know where this is at. Now, Ethan and anyone else, be careful on how this goes. First of all, you hit math, because he has a different calculator. You have to do something different. Go to prob, and then that's where you found your exclamation point, but now you find your NPR button. So it's math prob. Now, with an upgraded calculator, you get these blanks. You know what? I forgot. I can change the way my calculator looks, but I just don't have the time. We got to get done here. Those with an unupgraded 83, you get the NPR button. Raise your hand if you get NPR on the screen. Okay, those, you guys right here, I could actually upgrade your calculators. I could make it so that you have this happen in addition to get the fraction button on your calculator. So remind me, any of you, how many people have NPR instead of this? Hold up your calculators real quick. That one I can't, but it's fine. That's an older version. That one I can. All right, those are all TID4s. Don't worry about it. The 83s, you're going to just have to survive with just missing some features. I love the 83 Plus. I have that exact calculator at home, actually in here as well, and I use that more than any. But for you guys with an upgraded, you just do this. You unupgraded calculators, cancel, get that out. You have to type 9 first, then the NPR button, and then 9. And then what you're saying is N is 9 before, R is 9 after. Right? And then that's all you have to do, and then you'll get that same answer. So you can survive. You'll be fine. You just have to do something different. Perfectly good calculator. That thing's probably like 20 years old or so, and they're still work almost exactly the same as an 84. Okay, now back to the notes real quick, and just wanted to cover this. I tell you how to use the calculator, but then on your worksheet and on your next quiz, which we'll probably just wait till we're done with the unit and just have one quiz, there will definitely be a no calculator component. And actually, I constructed the worksheet on the bottom half with permutations and combinations to be done with no calculator. So this is what I expect you to do. Okay? So 6P4 on a test, you're going to have to tell me that that's 6 factorial. Well, I guess it's too far away. Over 6 minus 4 factorial. So I will expect to see this, and I will expect to see it on your worksheet, because this exercise is that you know what a permutation is, instead of being a button pusher and then copying the answer on your page. So that's why. Now, it's not 6 factorial minus 4 factorial. It's 6 minus 4, which is 2 factorial. By the way, what is 2 factorial? 2. But I'm going to write this the way I constructed your factorial simplification yesterday. I did that on purpose. To simplify factorials, this is what you want to do. Now, of course, 2 factorial is 2. And then this is what I would expect to have you have written on a no calculator. Meaning, just tell me what's left over. I don't want you to maybe calculate a big number. Although I think we should be able to calculate this. What's 6 times 5? What's 30 times 4? 120, just add a 0. 4 times 3, add a 0. And then what's 120 times 3? So I actually argue that this would not be out of the realm of actually calculating without a calculator. Next one, not so much. 11 factorial over 11 minus 3 factorial. Minimum, this is what I want you to understand. 11 times 10 times 9 times 8 factorial over, sorry, that should be in parentheses, 11 minus 3, which is 8 factorial. That's why I stopped up at the top. Never understood why seniors couldn't understand this in my statistics class. What is 8 factorial? 8 times, say it, 7 times what? 6, 5, 4, 3, 2, 1, right? And what happens to every single one of those numbers? They all cancel. Why write them out? Why? And why don't they understand? They just don't listen. Okay, that's what I feel. So what do I write for this one? Possibly you could have calculated this, but once we start getting pretty big, this is what I'm looking for. 11 times 10 times 9 is what's left over. Okay? Last one's just algebraic. What's up in the numerator? Come on, tell me. And what? Factorial over what's in the denominator. So what am I supposed to do about this? Well, it actually was in the definition on our first page of this set of notes, which was your last page yesterday. N factorial means n times n minus 1 times n minus 2. You just keep subtracting 1. Look where I'm at now. Times n minus 3, times n minus 4, times n minus 5. I could go forever, but look at the bottom. The bottom is n minus 3 times n minus 4 times n minus 5. I'm going to stop right there, just like in the previous questions. And what's going to happen with the n minus 3 factorials? What's going to happen with the n minus 3 factorials? They're going to cancel. So no matter what n is, np3 will be whatever n is times whatever n is minus 1 times whatever n is minus 2, and then that's it. So the factorials cancel themselves in this way. I like thinking algebraically because then it gives a rule about what kind of happens for something and it makes sense. Okay, not the greatest notes, couldn't care less. But I really want you to understand permutations order matters. When I made your worksheet, on the back of the worksheet, it's permutation combination. Which one do I use? I tried to make it real obvious because there are problems sometimes. I don't want to, rip on anyone, but there's sometimes I read a question and I can argue if order matters or not and how the question's worded. And I think it really has to be specific. And I think that's a problem sometimes with probability and a math teacher giving you something that has some gray area in it. Is this order matter or not? I really tried to make it so it was very specific. This is very specific. When I run a race, does it matter if you get first or second? Yes or no? Heck yeah, it matters. So here's the point of order mattering as opposed to order not mattering, and I don't want to see those repetitive scenarios. Say we have 4, 7, we have 10 right here in the last 3 rows. We all run a race. You 3 finish top 3. Does it matter if you would finish first, you second, you third, or you first, second, third, or blah, 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 blah? Does it matter, or yes or no? Because there's 6 different ways you guys can finish first, second, and third. All 6 of those matter because you get a different prize. You get the first prize or the third prize. So order matters. This is a 10p3. From 10 people, how many different ways can 3 people finish when order is important? Okay, so remember that going through all of this when I go to combinations. And I'm going to use these 10 people again. Now, this is one of those that's kind of a gray area, but then I can really make it not. I don't know if we do plays anymore. I thought we did one earlier in the year, and I feel like they're not doing them too much anymore. Anyone in the drama club? Anyone been there? Okay, does it matter what role you get? Yes, it's important. I got the lead role. Oh, I'm the person in the back, like I'm a secondary character. So it matters what role you get. And important also with the 7 dwarves. Are you sneezy or are you grumpy? I got different things that I got to do depending on which person I am. So it's kind of like in that little gray area range. But then when you think of it a little bit more, it's not. It matters. Say you 7 got picked for the play, but what's your role? What did you get for a role? Well, then that matters what you get assigned. Tough. All right. Sort of gray, but not really. Now, if I said from these 16 people, I'm going to choose 7 of them for the play. Was there anything specific there? Did it say anything about a role? No. So that would be a combination, right? Because if I get those 7 people, I don't want all the different ways that those 7 people can be picked. I got to get rid of the repeats, like the repeating letters in Bumblebee. Let's use that word. And then here you go. Here's combinations formula. I really want you to focus on that R factorial. There's the difference between permutation and combination. And you can guarantee that that R factorial has everything to do with Bumblebee and the repeated letters. The repeated letters in the word Bumblebee, it doesn't matter. You still have Bumblebee. In a combination, when order doesn't matter how I pick these 3, I don't want the 6 different ways that these 3 can get picked. They're picked and they're moving on. So that's the big difference between a combination and a permutation. You have to figure out, does order matter or not, and then choose the right one. All right? And not everything's a permutation and a combination. Sometimes it's like number 5 on your worksheet, it's a fill in the blanker. 11 times you spin and you can either get red or blue. How many different ways can that happen? That's 2 to the 11th. That is not a permutation or a combination. And that's where this gets kind of rough, so on and so forth. But they do kind of stick out what they look like. Usually it's like from a group of people, I'm going to get 3 people to do this. That's when you're dealing with permutations and combinations. So Mrs. Krabappel, right, chooses 5 people randomly out of a class of 20 students. How many different ways can she choose them? Anything specific? Do they win a prize for being chosen first? No, let's say it's for a field trip. Say I choose these 5 for a field trip. Does it matter if he gets picked first or fifth? Yes or no? No, he's going on the field trip. All right, that's the prize. It doesn't matter if he gets picked first or fifth. So, of these 5 people right here, if they get picked out of 20, there's 5 factorial ways that they can be picked of those 20. I don't care about those ways. That just means they're coming with me. So that's why that's 5 factorial right there, the dividing out of the repeats. So this is a 20 C5. All right? Making sure you understand that. Okay. All right. And then I gave one away, but I think it's pretty obvious. And it should be, because the roles, and that's what you have to think of, just like the 7 dwarfs. If I get picked to be one of the 7 dwarfs, the role that you get picked for matters. I was actually regenerating the questions on that worksheet, and I disagreed with some because they show the answers too, and I'm like, that's not a permutation, that's a combination. There's too much gray area in that. I think they're throwing more into that word problem that they didn't put in there in their mind. I firmly feel that. So, but look at the first one. Does it matter if you're president or vice president? Yes or no? Yes. Does it matter if you're president or secretary? Yes, it's different roles, it's different jobs, let's say. So this is a 25 from 25 people, permutate 3. Order matters. I get these 3. Well, who's president? Who's vice president? Who's secretary? All those ways that they can be arranged matter. So I don't want to divide those out. Permutation or combination, letter B. That's a combination. The potato just gets picked. It doesn't matter what order I pick the 5 of a group of 5. So I must get rid of the repeating ways they can be picked. 20C5 means I would have that. Sorry, I forgot to do something. Let's go back up to this space. I got to make up some questions. Actually, I was going to do this one. Let me calculate this. This is on the no calculator test. What? Okay, so go back to that page real quick. And I did do this one with the other hour. How am I supposed to do this on the no calculator test? Well, this is all you got to do. And this is why it's on the no calculator. I want you to know what the formula is. I could teach Lexi Samuelis, my 11-year-old, where the P and the C button is. And she can figure out how to calculate or hit the buttons on the calculator, press enter, and write the number on a piece of paper. I do a no calculator so that you know what the formula is, and then you walk out of here knowing what it is. Right? Then you can use technology to help you later. So, of course, the numerator is 20 factorial. The denominator, here's the change. 5 factorial times 20 minus 5 factorial. So I will check that on a calculator, no calculator part of the quiz, that you can write that and then watch what happens next. What's 20 minus 5, by the way? That's why I'm going to write the numerators 20 times 19 times 18 times 17 times 16 and then times 15 factorial. Because 20 minus 5 is 15 factorial. What's going to happen with the 15 factorials? Now I'm going to take 5 factorial, and I'm going to actually write that one out. 5 times 4 times 3 times 2, find times 1. And now I'm going to zoom in on this. Very, very doable. Okay, 15 factorials are gone. Hey, and by the way, what's 5 times 4? So what am I going to cancel that off with? 20. Okay, then maybe do this. What's 3 times 2? Who does 6 go into in the top? How many times? Now, don't lose your stuff here. So here's what I expect you to write as a final answer. 19 times 3 times 17 times 16. Circle it up because obviously that's a ginormous number. So the point of this being no calculator, I'm making you exercise what a combination is, do some canceling, and then just leave the answer as a product. On the worksheet that I created those permutations and combinations at the bottom, and I put a key with what I think should have been canceled, and that's how the answers are listed. You got it? Okay, that's always on page 3 and 4 on the posted worksheet online when I use the software to do this. Okay, and then how about the last one? What about a seating chart? Does order matter or not in a seating chart? The whole point of a seating chart is where you sit, and that is the order. All right, so yes. So I have 30 desks, and I have to place 22 students. Since order matters, it's a 30p22. That's how many different seating charts I could come up with. Of course, I always come up with one every year. I just put you alphabetic because I don't care. And then how about the last one? This was hilarious. It was a 50-50 second hour that got this right. Read it. And then, those, we'll raise our hand at the same time. Right hand permutation, left hand combination. So when I say raise your hand, right hand you think it's a permutation, left hand is a combination. 3, 2, 1. Raise your hand. So I got right, left, left, left. I hit right, left, 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 right. This is interesting. Right, left, left, right, left, 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 right, left. Is your hand up? Left. Is that left? And then right. Boy, I think it was more lefts than right. What did I say left was? Combination. It's a combination. There is nothing that says you get a first place prize, second place prize, third. What happens if you get picked? You just go where? National television. There is no prize for being picked first, second, or third. Everyone wins, and it doesn't matter how order you got picked. If I pick these 10, I don't care how they were picked. You're going to TV. Okay, so it's a C. That's the thing. That's the trick. All right, and I did want to end with this because I find it interesting. And actually, this book is probably where I grabbed this from, and it doesn't matter. We're just doing math, but I think I grabbed this from 2003. And if this was truthful in 2003, it's not anymore because the lottery, they want the odds better for the state. They don't want you to win as much. But if you ever seen Lotto, Illinois Lotto, anyone ever see the old fashioned the balls rolling and then they collect? Anyone ever see that? Okay, and they used to do that. Now I'm a little suspicious. It's all computerized, which makes me a little funny. But for the lotto, the balls would come and it would be like 11, 50, 2, 7, and then at the end they'd rearrange them in order, smallest to biggest. So does order matter or not when you're playing the Illinois Lotto? It actually doesn't. Right? And that's what's funny. On some other games, the order does matter. Like pick 3 is another small game that the Illinois runs. Pick 3, if I pick 1, 2, 3, and 3, 2, 1 comes up, I do win a small prize, but I don't win a prize for having them in the correct order as well. So that's different. For lotto, lotteries in Illinois, anyone ever hear of Mega Ball? Anyone ever hear of Powerball? None of those, the order doesn't matter. So it's a combination. So for this Georgia lottery, you pick 46 numbers, or you have a pick from 46, and it's a C6. I remember Illinois Lotto, I think when it first came out, was only 40 numbers. All right, when my mom and dad started playing. Now it's 52. What do you think happens when you add the numbers? What does it do to the amount of ways? It greatly increases. So 46C6. Come on, help me out. What is that? Speed it up here. What's 46C6? Try to sprout out the number. Anyone got it? Raise your hand when you got it, and then you can tell me. Yes? So that means that's how many different numbers there are. If it was $1 a ticket, you could spend $9 million, 369 million, 300, blah, 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 that much money to buy every single possible ticket. So what if the Georgia lottery was $20 million as a prize? Would you do it? Would you do it? What happens if you win and somebody else wins? What happens with that 20 million? You split it. Here's another thing. Do you know how much the government takes? 50% at least. Then here's another thing. This is if you take, usually this is how the lottery works. If it was $20 million, that's if you take it over 20 years as like what's called an annuity. If you take a lump sum, you get less than what the grand prize is. They got a lot of ways that it doesn't work out that way. All right. And it's kind of funny how that works. Hey, by the way, I just told you Illinois is 52. Now, even when you see this number, good old Mr. Samuelus, the mathematician, still plays one number every once in a while. But this is his chances of winning. There's only one number pulled out of what's 52C6. What is it? Did you say 358 or 68? And then what? Now, I'll tell you right now, the Illinois Lotto right now, the prize is like $2,500,000. There's 2,500,000 payout. So there's 20 million different numbers that you. The probability of you winning is 1 divided by that. That's your probability with playing one number. Oh, I forgot to tell you, the Illinois lottery just changed from $1 ticket to $2 a ticket. Yeah, so there you go. Now they do have a funny little thing that you can win 2 other ways, but believe me, them adding it $2 and adding 2 different ways to win, they're still making out. Remember what I told you about gambling? The more you gamble, the more you are definitely going to what? Lose. Whoever said win. We got to help this guy. All right. And then Mega Millions is really weird. And I may have this wrong. I forget how many people know Mega Millions. It's called Mega Ball or Powerball. There's an extra ball at the end. So it's actually you pick from 5 numbers, and I don't know. I looked up Powerball, and I don't want to give up the Powerball thing. And I think it's out of a list of 52. Then you pick one number, that's the Powerball, out of a list of like, I think Powerball is like 26 numbers. So I think I'm kind of doing this question for you here. So here's how this is different. And I think this 52 might be wrong. It might be even more numbers from there. So from the first set of balls of 52, you pick 5. Still, the order doesn't matter. What they do at the end is rearrange them in order from smallest to largest. Then you pick from a set of 26. And you do multiply that because there's 26. Actually, 26C1 is 26. So after you choose the first 5, then there's 1 through 26 that you have to choose from after that. That's called the Powerball. Now notice this doesn't seem much different than this, but I wanted to equate these two and how just making that change from choosing from a different list, even a smaller amount of balls, I bet you some people think this would be smaller than that number. It's not. It's actually way larger. So Powerball and Mega Ball made it even harder to win, but that's why the money goes, crazy, how much those pots are. Did anyone type that in? I just want to know how many million at least. More than tripled, right? More than tripled, 67 million. And I think the amount of balls that they use is actually more than 52. So I just wanted to end with that. I'll stop the notes.